Hello, welcome to Helping Math. In this video, I'm going to show you how to perform a partial fraction decomposition. First of all, let's get to the procedures how to perform a partial fraction decomposition. But first of all, let's understand what's the essence of the partial fraction decomposition. So in reality, the partial fraction decomposition is the inverse process of combining two or more rational expressions. For example, let's say we have 1 over x minus 3 plus 2 over x plus 2. And actually, using the algebra technique, we'll be able to get to a single rational expression, 3x minus 4 over x minus 3 times x plus 2. So by using the LCD and combining both rational expressions with the LCD, I will get to the single rational expression. And the partial fraction decomposition basically is we have single complex rational expression. We try to break it down into partial fractions. In this case, we break down into two partial fractions. And here, the key thing is to find out what is the term on top of the first linear term, and then what's the constant on top of the second linear term. Meaning, basically, we just try to figure out what is A and what's B. And from the original source, we know A in this case is 1, B in this case is 2. Later on, I'm going to show you some examples on how to use the algebra to get to the A and B step by step. But before we can do that, let's look at the rules to conduct a partial fraction decomposition. The rule for partial fraction decomposition of f of x over g of x. So we have rational expression here. This is rational expression. And notice that both f of x and g of x are polynomial functions, and that g of x cannot be 0. And basically, we have several steps to follow. First of all, we need to look at whether f of x over g of x is improper. If it's improper, we have to divide it using the long division. And if it is proper, we can move forward to the next step. But if it's improper, then we divide it first using the long division. And after that, we perform a partial fraction decomposition on the remainder part, remainder over the g of x. Right. So this is the very first step. And step 2, we need to also completely factor the denominator into the product of the factors in the form of px plus q, parentheses raised to n power, and ax squared plus bx plus c to the n power. And we call this px plus q is a linear factor. And ax squared plus bx plus c, that's a quadratic factor because it's a quadratic term. And you only allowed to have two types of factors, linear factor or quadratic factors. Also, quadratic factor must be irreducible, meaning you cannot factor that anymore, right? So this is complete factor. Step 3, for each factor in the form of px plus q raised to n power, a partial fraction decomposition must include the following sum of m fractions. Okay, so we have a1 over px plus q, and adding a2, so this is the first term. and the second term is a2 over px plus q to the second power, and then m, the last term, m term, is am over p of x plus q to the n power. And here a1, a2, am, they are all constant, right? So this is very important. So that means on top of the linear term in the denominator, the top must be a constant, right? So constant on top. Constant linear term. Basically, you reduce the power by 1. That's how you end up with the constant term. Okay. So remember that for the linear term, on top of that must be a constant. And now for each quadratic terms, right, like ax squared plus bx plus c to the nth power, the partial fraction decomposition must have the following sum of the nth fractions. First one is this is first term. So b1x plus c1 over ax squared plus bx plus c first term, and second term b2x plus c2 over ax squared plus bx, adding c raised to the second power. So this is the second term. And we abbreviate some of the terms in between. And the last term will be n term. Will be bnx plus cn over ax squared plus bx plus c to the n power. And again, right here, b1, b2, b3, b4, all the way to bn, they are all constant. c1, c2, all the way to cn, they're all constant. So that's an important thing to recognize. And now once we go over all this process, then we're ready to look at some of the examples. So I'm going to get to the, okay, I'm going to take you to the note, and now we're going to look at the first example here. Okay, so in the first example, we want to do the partial fraction decomposition of following rational expressions. So right here, you look at the denominator. So they both, if you look at them, they are both linear term, right? So that means this on top of linear term must be a constant. So on top of the first linear term is a over x minus 2. On top of the second linear term must be b over x plus 3. Okay. And right here, the key thing is to figure out what is a, right? We don't know a, we don't know b. Just figure out that. And first of all, just gonna combine those two terms on the right using the LCD. So the LCD here is x minus 4, x plus 3. So simply copy down the left-hand side. On the right-hand side, now for the first fraction, we're going to multiply both top and bottom by using the LCD. Right? We're just checking what is missing, the missing linear term. For the second part, we multiply by both top and bottom by x minus 4. Okay, I should write the other one first. So quickly erase this. Okay, so x plus 3 goes first, and x minus 4. Notice that we multiply by the same factor to get to the LCD. So now from here, we combine the right hand side. Still, left hand side remains the same. Okay, so we get a times x3 plus b times x minus 4. The denominator will be the same, it's x minus 4, x. Now, if you look at it, now we have the same denominator. Right? So that means when we have two fractions on the left-hand side, right-hand side, when the denominator are the same, then the numerator must be the same. That means 5x minus 6 must be equal to 8 times x3, adding b times x minus 4. And there are a couple different ways of solving for a and b right here. First one is using some algebra trick. Right? So if you look at it, the key thing is we try to eliminate one of the variable. The only two variables we concern here is a and b. So in order to get the x a values, the value for a, and we want to make sure b is not here. So if you observe this equation, when x equals when this term, so 4 goes here, then this b term is gone. So that means for the entire equation here, the only variable we have will be a. So we have on the left-hand side, so plug in the 4 here. So we get 5 times 4, 6 equal to 8 times 4 plus 3. So this is 20 minus 4 on the left, 14. On the right is 7, 8. That means 7, 8 equal to 14. And from here, we divide both sides of the equation by 7, so a equal to 3. Okay. So that's how we get to the value of the a, right? So then we're gonna learn how to get to the value of b by using a similar method. So right here, if we're assuming when x equal -3, so we go back to this equation here. When this x right here becomes -3, then a term is gone, right? Because -3 plus 3 gives us 0. 0 times a becomes 0, and we only have the variable b left. So let's plug in the -3 on the left-hand side. We get 5 times -3 minus 6, and this term right here becomes 0 because -3 plus 3 is 0. 0 times a is 0. On the other one, on the variable b left, so -3 minus 4. Now simplify, we will end up with -15 minus 6. That is equal to -7b. Then let's simplify. So -15 minus 6 is -21 equal -7b. And in this case, b is equal to -7b equal to -21. So b equal to 3. Dividing -7 from both sides of the equation, b is 3. So again, this is one way of solving this. Another way, I'm also going to show you another way of solving this. So 5x, let's copy this. 5 minus 6 equal to 8 times x3 plus b times x minus 4. Another way is by setting up a system of linear equations. So here, on the left-hand side, we have two terms, linear term and a constant. Copy that. On the right-hand side, we have linear terms. So let's distribute this ax plus 3a plus bx minus 4. And ax plus bx, that's a linear term. Combine them together, so we get a plus b times x. And the other two terms, 3a and minus 4b, those are the constants. Put them together. So now linear term equal to linear term, constant equal constant. That means a plus b must be 5. Okay. 3a minus 4b must be -6. From earlier algebra course, we know that we can solve for a and b. So in order to solve for a, we can multiply the first equation by 4. The entire equation by 4. So we get 4a plus 4b equal to 20. 3a minus 4b equal to -6. So now we have two opposite terms, plus 4b minus 4b. When you combine these two equations, adding these two equations, we end up with 4a plus 3a is 7a, plus 4b minus 4b cancel each other. 20 plus minus 6 is 20 minus 6, 14. So in that case, we know that a is equal to 2. So same result, right? Like earlier, from earlier method. And now once we know a, now I plug a into the original equation. So we have 2 plus b equal to 5. So subtract 2 from both sides of the equation. So the b value equal to 3. Yeah, so totally up to you. Both methods are good, and depends on your preferred method. So in this case, we actually get to the final result. Right? So the final result here is 5x minus 6 over x minus 4 x to 3 must be equal to a is equal to 2 and then b is equal to 3. So that's equal to 2 over x minus 4 plus 3 over x plus 3. And this is our result. And you can apply this in calculus too, because we have the final antiderivative or the integral of 5x minus 6 over x minus 4 times x plus 3. You can break down into this two partial fractions, and eventually you will be able to find an integral for each one of these. But that's when you get to the calculus too, right? Okay, so now let's take a look at the partial second example. All right, this example we have two different types of the denominator. First one is a linear term, so this is a linear factor, and this is a quadratic factor. And right, so we're still gonna decompose it. And first of all, we know that on top of the linear factor must be a constant, so a over. Okay. And then on top of the quadratic factor, right, it's a linear term, so it's ex plus over x squared plus 2x minus 1. So now, please use the key thing to find out what is A, what is B, what is C. And again, we're going to use an LCD, right, on the right-hand side to get to the simplify this. So let's copy the left-hand side, 5x squared minus 10x minus 7. Okay, the denominator is x minus 5, x squared plus 2x minus 1. And we know LCD here is x minus 5 times x squared plus 2x minus 1. All right, so for the first term, we multiply both top and bottom by the quadratic factor, x squared plus 2x minus 1. Okay, on the bottom, same thing, x minus 5 times x squared plus 2x minus 1. So for the second term, we're going to multiply both top and bottom by x minus 5. So 3x times x minus 5 on the denominator. Same thing, multiply by the same linear factor, x minus 5. Okay, so now we have this same denominator that we can combine them. So on the left hand side, that's 5x squared minus 10x minus 7, x minus 5, x squared plus 2x minus 1. Yes. So now on the right hand side, combine the single rational expression, which is x minus 5, x squared plus 2x minus 1, then a times x squared plus 2x minus 1 plus, so we distribute this, okay, dx later, no, distribute out later, x minus 5. So now we have the same denominator. Again, that means numerator must be the same. So 5x squared minus 10x 7 is equal to a times x squared 2x minus 1, adding dx t times x minus 5. Now, right hand side, we can distribute it by like terms. We can also use the method formula. So I guess I'll show both methods as well in this case. Okay. So okay, let's start with the first method. If you observe this, if you're making x equal to 5, when x equal to 5, that x equal to 5, then this both, so this term basically becomes 0. And that means we only end up with the variable a, right? So plug in the 5 here, and then 5 the rest of them. So 5 times 5 squared minus 10 times 5 minus 7. On the right hand side, we get a times 5 squared plus 2 times 5 and minus 1. Okay, and this term 5 minus 5 becomes 0. 0 times dx for c becomes 0. Now from here, we can simplify. So this is 125 minus 50 minus 7. On the right is 25, adding 10. 35 minus 1, 34. So 125 minus 57, that's 68. Hold on, 125, 75 minus 7, yeah, it's 68. Okay, so 68 over equal to 34a. So that means 34a equals 68. So in this case, a equal to 60 over 34 is 2. Okay, so a equal to 2. Okay. Now, since we know a, now let's figure out what is the b. Okay. So now, if you look at a quadratic term, 5x squared, right? Then on the right hand side, there's only two square terms, right? Square term 5x squared on the left, on the right. So 5x squared must be equal to ax squared plus bx squared. Okay. That means 5 is equal to a plus b, because the square term, so factor by x squared, you get a plus b. So 5 equal to a plus b. So if you know a equal to 2, b must be 3, because 2 plus b equal to 5. So b equal to 3. Okay. And once we know b, then we can also find out c, because if you just extract the constant term, okay, so the constant term comes from two parts on the right. So step 2, step 3, the constant term on the left is 7. On the right must be from a times -1 and then c times -5. So -7 actually is equal to -a minus 5c. Now again, if we know a values, a is 2, 2 here, and we can figure out the c values. -7 equal to -2 minus 5c, and adding 2 from both side equation, we simplify this expression, and over -5c equal -5. Now dividing both side equation, and by -5c. So now we find out a, b, and c, right? All three numbers. And also we can just take another approach, meaning let's copy this. Copy 5x squared minus 10x minus 7. On the right, it's a times x squared plus 2x minus 1. The other term is bx plus c times x minus 5. So the other method is basically distributing the left-hand side, right? All the terms on the left, and foiling this. All the terms. So the 5x squared minus 10x minus 7. So it's ax squared. And when the partial fraction decomposition becomes more complicated, actually this is a more systematic way of solving for a, b, and c. Okay, so we get 2ax minus a. And when following the other one, 3x times x is bx squared. Bx times -5 is minus 5bx. C times x is plus cx. And c times -5 is minus 5c. Okay. Now let's combine the like terms. Put the like terms together. Ax squared and then bx squared, they are like terms. So factor out x squared, we get a plus b x squared. And then we're going to put a linear term together. This one linear term, linear term, linear term. Okay, so again, factor out the x, we get a 2a minus 5b adding c times x. And then the constant term, only two constant terms, minus a minus 5c. So minus a minus 5c. Now we split up into three different terms. Now 5 must be equal to this. Right? -10 must be equal to this. -7 must be equal to this. Okay. So now actually we get a system of linear equations. First one is a plus b. So the coefficient for the square term are the same. Coefficient for the linear term must be the same. And coefficient for the constant must be the same. So it's minus a, 5c, that's equal to 7. Now in this case, we can learn to solve for the a, b, and c, right? So one way to do it is, in this case, for the first equation, get a by itself. We can easily get a by itself, so a is equal to 5 minus b. Okay. All right, and then for the last equation, get a by itself as well. So you get a is equal to negative a equal to minus 7 adding 5c. And All right, so the A is equal to 7 minus 5C. Okay. So in this case, these two equal to each other because they both equal to A. All right, so we have a 5 minus B equals 7 minus 5C. So then we solve for B. Okay, so minus 5 from both sides of the equation. So that negative B equal to 2 minus 5C. And then so the B equal to negative 2 adding 5C. Now, we haven't touched the second term. So we're going to plug this into the second equation here. So here. Once we figure out one of the variables, the rest of them will be there. So this one goes in the second equation. And also we know that A is equal to, so now we change B to C. Right? Also we need to change A to C. So A goes in here. So now we get a 2 times 7 minus 5C minus 5 times negative 2 plus 5C. That's equal to, no, not yet, adding C. Okay. That is equal to, let's distribute it. We get a 14 minus 10C adding 10 minus 25C adding C equals negative. Okay. So combine all these C terms. Right. So minus 10C minus 25C adding C, that is negative 34C. 14 plus 10, that's 24. That's equal to negative 10. Let's subtract 24 from both sides of the equation, we end up with negative 34C equal to negative 34. Now you see we figure out the C values. C equal to 1. And it should be exactly the same as the previous method. We just did right here. C equal to 1. So it's the same. All right. And now once you have C, then we know how to figure out B, right? So B is equal to minus 2 plus 5C. So it's minus 2 adding 5 plus 1. B is equal to 5 minus 2 is 3. Same. So once we know B, then we know A. B goes here. Okay. So the A equals 5 minus B. Okay. So it's 5 minus 3. So A equals A2, B3, C1. Yeah, so it's that same result as previous one. Okay. And eventually we're going to write the result. Okay. So the result here is this is actually equal to A is 2. So this is equal to 2 over x minus 5. B is 3, so 3x. C is 1. Adding 1. And over x squared plus 2x. So yeah, that's basically how you get to the bottom of this quadratic fraction decomposition on this particular example. Yeah, that's pretty much everything on this video.